Recently, astronomers have discovered the largest black hole to date. The total length of its jet has reached 23 million light-years, equivalent to 140 Milky Way galaxies lined up end to end. Its total energy output is equivalent to trillions of suns. An international research team announced this discovery on the cover of the journal Nature. This flaming dragon is named Porphyrion, and its history can be traced back 6.3 billion years ago, almost half of the history of the universe. The cosmic web that connected and nourished galaxies in the early universe was denser than it is now, which means that such a huge jet covers a considerable part of the cosmic web. The Pan-European Radio Telescope Array combines a wide field of view and high sensitivity to extended structures. It surveyed about 15% of the sky. It was in such a small space that more than 10,000 jets were discovered, and Porphyrion is just one of them. Before this survey, astronomers only knew a few hundred jets in total. The observation results located the source of the jet to a huge galaxy 7.5 billion light-years away. The observation results also indicate that it was born from an active black hole in the radiative mode. A radiative mode black hole usually refers to those black holes with a very hot accretion disk and high luminous efficiency, while a jet mode black hole refers to those that can produce high-speed plasma jets. Radiative mode black holes are more common in a young or more distant universe, while jet mode black holes are more common in the current universe. This discovery means that what we see may be just the tip of the iceberg, and there are more giant jets waiting to be discovered. Such a huge jet structure requires an extremely stable and active supermassive black hole to maintain. That is to say, this black hole must continuously accrete and swallow matter for hundreds of millions of years and ensure that the jet points in the same direction throughout this period. It was only in recent decades that astronomers realized that the evolution of galaxies and their central black holes is closely intertwined. In addition to heating the gaseous matter in their hosts and preventing star formation, jets can also magnetize the matter between galaxies and galaxy clusters. Astronomers believe that this phenomenon is very likely a relic of the Big Bang itself, and black hole jets have designed this process and overseen the delicate ordering on a cosmic scale. Scientists have observed quantum entanglement between quarks for the first time. This is a state in which particles mix with each other and lose their individuality, and can no longer be described separately. For decades, people have been testing entanglement in particles, such as electrons and photons. This is a subtle phenomenon and is easiest to measure in a low-energy or quiet environment, such as in the ultra-cold refrigerator of a quantum computer. If it is a collision between protons in the Large Hadron Collider, it is relatively noisy and high energy, and it is very difficult to measure entanglement from its fragments. It is like someone whispering to you at a concert, and it is very difficult to hear clearly. In order to observe entanglement at the Large Hadron Collider, physicists analyzed about 1 million pairs of top quarks and anti-top quarks. They are the heaviest particles among all known elementary particles and their antimatter counterparts. They found statistically overwhelming evidence of entanglement and successfully captured the quantum entanglement between top quarks and anti-top quarks in a high-energy environment. The detailed research results have been published in the journal Nature. Previous studies have found that during the short life cycle of top quarks, they can have an associated spin, which is a quantum property similar to angular momentum. Scientists realized that this measurement could be extended to show that the top quark spin is not just correlated to some extent, but truly entangled. The pairs of top quarks and anti-top quarks produced after proton collisions can only last for 10 to the power of minus 25 seconds and then decay into longer-lived particles. This short-lived property of top quarks has become the key to the research. Top quarks decay fast enough so that they do not have time to hadronize and lose their spin information through mixing. Instead, all this information is transferred to their decay particles. This means that researchers can measure the properties of their decay products to infer the properties of their parent top quarks in reverse, including spin. The successful measurement of entanglement in top quarks can improve our understanding of top quark physics and pave the way for high-energy entanglement tests. In the future, even the Higgs boson can be used to conduct Bell tests, which is a more rigorous test of entanglement. All the gas planets in the solar system have rings. Some scientists believe that the moons of Mars may be the remnants of ancient rings. A recent study suggests that the Earth may have once had a ring similar to that of Saturn. It was formed by the disintegration of an asteroid 460 million years ago. This event coincided with a large number of meteorite impacts, mainly occurring near the equator. Subsequently, the global temperature dropped significantly. The geological and climatic anomalies during this period, including the increase in meteorite fragments and the start of the Ice Age, are all related to the shielding effect of this hypothetical ring. The story may be like this. A long, long time ago, an celestial body was torn apart by the Earth's gravity and then split into countless fragments. All these fragments pushed and squeezed each other and gradually evolved into a debris ring rotating around the equator. When they fell, they became meteorite craters. Therefore, if the Earth destroyed and captured a passing asteroid about 460 million years ago, it could explain the abnormal location of the impact craters, the meteorite fragments in the sedimentary rocks, the meteorite craters and tsunamis, and the relatively short exposure of the meteorites to space radiation. The biggest unsolved mystery in the field of astronomy may have just been solved. A recently published paper reports that they may have found the source of WOW. On the night of August 15, 1977, the Big Ear Observatory received a mysterious deep space signal. It was exactly in the area that the city community had been focusing on. The signal was very powerful, but it quickly disappeared into the night and has never been heard again since. The next morning, they found these data on a printout, circled them, and wrote WOW. Since then, this signal has been called WOW. Actually, this kind of signal is very close to an existing natural phenomenon, that is, the cold hydrogen cloud. The cold hydrogen cloud is a cloud-like structure formed by the aggregation of hydrogen atoms in interstellar space. Because of its low temperature, it is called the cold hydrogen cloud. It is just too weak to reach the intensity of an alien civilization. And a pulsar can emit a concentrated microwave energy beam similar to a laser. When it contacts the cold hydrogen cloud, the signal of the cold hydrogen cloud can be amplified, so it looks like a lighthouse from a distant civilization. When you calculate the emission lines and temperature, you can understand that those are just clouds that can be seen everywhere. So why wasn't this hypothesis proposed in 1977? Because at that time, magnetars had not been discovered yet, and there were almost no space sources that could emit masers at that time.